In this video, we'll explore the different water sources included in the WaterWise inventory for the United States. As mentioned earlier, each water source follows a distinct methodology, and our analysis is conducted at the community level across the contiguous U.S. on an annual scale. Using GIS tools and models, we estimated the available water volumes for each source. The water sources in WaterWise are categorized into two main groups: traditional sources, surface runoff, and recharge; reuse sources, rainwater, stormwater, treated wastewater, and agricultural runoff. Let's start with the traditional sources, which represent naturally occurring water availability. Here we see an example of Ames, Iowa, with its drainage area highlighted in green and the city boundary in red. This helps illustrate how we estimate these traditional water sources. Surface runoff is calculated by defining the watershed that drains into the city's main accumulation point. We then integrate runoff data spatially and temporally to obtain the annual surface runoff volume available for each city. Recharge follows a similar approach, but instead of runoff, we focus on groundwater recharge rates from the Water Atlas dataset. This process represents the amount of water infiltrating underground aquifers, which is crucial for long-term water availability. For these traditional sources, the visualization highlights the watershed in green to show the area contributing to water availability. Now, let's move to the reuse sources, which capture water that can be harnessed through engineered solutions and conservation efforts. Rainwater is estimated by considering only the precipitation that falls on building rooftops. We use CMIP6 climate model data, along with FEMA's building footprint dataset, to determine the total rooftop area, shown in gray in the image. This allows us to calculate the potential rainwater collection for each community. Stormwater also relies on CMIP6 precipitation data, but instead of rooftops, it considers all developed areas, classified as low, medium, or high density. The rational method is applied with different runoff coefficients based on urbanization levels. In the visualization, these areas are color-coded: yellow for low-density development, orange for medium-density development, gray for high-density development. Treated wastewater is estimated using a dataset of wastewater treatment plants. The available volumes represent treated water that could be repurposed for non-potable uses. The image shows the wastewater dataset as a raster, where each pixel provides the estimated treated wastewater volume for that location. Agricultural runoff considers surface runoff from cultivated land within each place or community. We identify these areas using land cover data, focusing on croplands. In the case of Ames, the primary crops are corn and soybeans, and those agricultural fields are highlighted in the image. After estimating these volumes at the community level, we aggregate them to larger scales, county, state, and watershed levels, allowing for broader regional analysis. Understanding these different sources helps users assess water availability based on location-specific characteristics and land use. WaterWise provides a detailed and interactive way to explore these sources and support decision-making. Now that you've seen how we estimate water availability, continue watching our next videos to learn more about how to use WaterWise effectively.